So yeah, now that we're in the configuration stage, let's go ahead and start configuring everything, right? So again, server, let's give this a, we're gonna statically map it because there's no DHCP running in that network, so that the server can't broadcast and go through the whole DORA process and whatnot to get an IP, which again I will explain to you guys later in the upcoming video. 0.0. Default gateway in this case would be, again, the first hop here, or the hop in which all the traffic will go to. .1 in this case. So while that's not the definition for default gateway, in this scenario, that's what it is. Okay, let's see here. Okay, so that's that. Now, whoops. What am I doing? So let's go ahead and give it a host name. So host name, INET router. Okay, so this is the internet router for your enterprise network. Okay, so now int gig01, let's give it an IP address that we have already assigned, or we already carved out and designed, 6164.100.1, and the subnet mask of /30 is, yeah. So no shut, right? Always no shut and new port if you want to bring it up. That's that, and let's do it right, mem. Now it's turning green, so let's go ahead and ping the other side. 100.2. Come on, Mr. Verstappen. All right, so we're good. From point here, you ping, and it's good. Well, this is starting to look weird. Okay, so now that's done. Now we gotta go inside. Same router, internet router. Let's configure the downside, or downlink, downstream. Internet interface, rather, interface gig 000, IP address. Sorry, I didn't explain. So you can either do int or interface. I like to interchange. Sometimes I do this and then just alt tab in real life scenario. So int gig 0, we already did that. So IP address 10.10.10.1 to no shut. All right, so that much is set. Now let's go ahead and configure here. So password for default Cisco ASA is nothing. Just press enter, and then host name. What's the host name? Enterprise firewall. So that. So one thing about these ASA 5505s, they're pretty unique in its own way. There's nothing like a 5505, meaning a 5505 acts as a hybrid beast. So it really essentially acts as a firewall, a switch, and a router. So that's not really a hybrid. It's like this trifecta, right? It's a thing of beauty because you can do a lot with so little. And unfortunately, it's end of life. But let's go ahead. You can still learn a lot about ASAs, switching and routing all in one in an ASA 5505. You can get it on eBay for like $100 with a security license. Anyway, in a 5505, you need to create SVIs or VLANs or interface VLANs. All right, so interface VLAN 2. Let's create interface VLAN 2. Let's give an IP address of 10.10.10.2 to security level 0. Okay, name if outside, no shut. And then what that means is enterprise here to where's my marker? So from here, from this interface, you can ping this interface now. Well, you should. 1. Now, there's something that you need to know about firewalls. There's a difference between, where's my marker again? In a firewall, right? There's a difference between traffic sourcing from the firewall and out, and then it's another thing to have traffic going through the firewall. So again, you always remember that in a firewall, there's a difference again. There's a difference between traffic going through the firewall, like let's say from here or another end host, end user. There's a difference between this. I just love drawing. And then there's a difference between starting here and then going out. In this case, we started from the firewall. Hence we don't need ACLs. But let's see, let's keep moving on. Let's build this out. Another thing is that we, at this moment, let's bring this back. We created one security zone or security level, right? Security level 0, which almost always is tied to the outside interface. Name if outside security level 0. Just grind that to your head, okay? Security level 0. Name if outside, okay? And the inside is almost always security level 100. Again, outside, inside. 100, 0. This config comes with ASA 5505s by default. So I guess to minimize the confusion, we could have chosen. So I'm going to stick with VLAN 1 in this exercise because again, it's very simple, and by default, again, these switches are all VLAN 1. Everything's just VLAN 1, and that's just default. You can always obviously change this to VLAN 2, but then down here you'd also have to change, or actually no, because 2 is already here. So let's say VLAN 3. You'd have to change VLAN 3, and all the traffic from VLAN 3 would go up here if you have an interface VLAN 3. But anyways, in this scenario, again, inside, outside, VLAN 1 was already created, but we wouldn't have any problems creating them ourselves. What we're essentially saying is this: look, in security levels and ASAs, you have the outside and the inside. Okay, inside equals, change color, 100. You have a level of 100, which is the highest it can go. What that means is that whatever is in this interface or this security level 100, that means that it can go into any other name ifs or zones in which it has a lower security level. So what this means again is we have the outside with security level 0. Inside can always go out this way. 100 can always go into 0. Inside can always go out. That's what it means. Now this is not too complicated, right? But when you add like multiple DMZs, that becomes sort of tricky. So let's say you create another interface VLAN 3, and here you have a DMZ network, and you want some kind of traffic policing here, then things get a little tricky. But again, it still doesn't change the fundamentals of security levels and security zones. So DMZs, let's say you can essentially give it any number, but in DMZ, giving it a security level of 30, what you're essentially saying is the inside can always access DMZ 30, right? And the DMZ 30 can always access anything in the outside interface or anything with security level 0. However, again, outside interface cannot enter the DMZ without ACLs. You can't initiate unless things get a little tricky here. It depends on where you initiate traffic, but again, that's another lab or another video. But inside can always access 30. DMZ can always access outside 0. 100, 30, 0. 100 can always go into 30. 30 can always go into 0. However, DMZ, because it has a security level of 30, it can never go into, the flow of traffic cannot go into the inside, which is your enterprise your enterprise network. Okay. So again, just to recap, highest is always inside 100, lowest is 0 outside. Outside being dirty, where a lot of suspicious and malicious activity is out in the outside. But this is a very simple but a important topic that I will definitely go through in more, I guess, detail later on. But again, for now, we're just gonna have two security levels: 100 and 0, outside, inside. That's it. Okay. Now that we have that set, we need to attach these interface SVIs to an interface. Now, you do that by going interface. So we have Ethernet 00. So Ethernet ETH00. And what we want to do is security switch port mode access, switch port access VLAN 2. I know you noticed that it was already there, but again, by default it did that. But this is, I'm just showing you in the event that, let's say you have that interface, let's say you have the DMZ network off of interface VLAN 3, you can just go and add a interface VLAN 3 here. You'll also notice that 01, there's no config underneath it, and the reason being is that by default, if it has no every interface has to have a VLAN on it, right? By default, you don't put a VLAN underneath or attach an SVI to an interface, it will give it 1, your default VLAN. Let's see, so show VLAN, so switch VLAN. Like I said, Ethernet 01, Ethernet 01. Normally I would just put the config switch port access VLAN 1, switch port mode access, but in this case, again, by default it already attached itself to the first interface. Okay, so that's pretty much set, and again, that's why I want to keep interface VLAN 1 or just use VLAN 1, because everything is by default already set up. Same thing for the switch. I'm not going to do any work on this switch because for now there's no interface VLAN 1 here. It's shut down because it's all the way up here.